Preventing chatbot from spreading false or misleading information. This YAML file outlines the crucial steps and considerations involved in preventing chatbots from disseminating false or misleading information. It addresses the importance of building trust and accuracy in communication by mitigating the spread of misinformation. Inputs. Chatbots require diverse input sources, including user queries, text data from various platforms like news articles, social media posts, and other sources of information. These inputs feed the chatbot's knowledge base and enable it to respond to user questions. Training a chatbot on a comprehensive dataset that encompasses both accurate and inaccurate information is essential. This exposes the chatbot to a wide range of data, allowing it to learn to distinguish between truth and falsehood. Outputs. Chatbots should strive to generate responses that are grounded in facts, accurate, and unbiased. This ensures that users receive reliable information and are not misled by the chatbot's responses. Confidence scores serve as a crucial indicator of the chatbot's certainty regarding the accuracy of its responses. These scores can help users gauge the reliability of the information provided, encouraging critical thinking and reducing the risk of spreading falsehoods. Working methodology. Training a chatbot on a large dataset that includes both accurate and inaccurate information is a foundational step in combating misinformation. This exposure allows the chatbot to learn to identify and differentiate between reliable and unreliable information. Implementing techniques like fact-checking, source verification, and bias detection is essential to ensure that the chatbot's responses are grounded in truth. Fact-checking involves verifying information against reputable sources. Source verification ensures the credibility of the source, and bias detection aims to mitigate any potential biases or manipulation. Empowering users to flag potentially false information through feedback mechanisms is crucial. This enables continuous improvement by allowing users to highlight instances of misinformation and contribute to the chatbot's learning process. Transparency in the chatbot's information presentation is essential. Providing users with context and sources for the information presented enhances their understanding and allows them to critically evaluate the chatbot's responses. Prerequisites. Access to a large and diverse dataset of text data is crucial for training a chatbot capable of identifying and mitigating misinformation. This dataset should encompass a wide range of topics and perspectives, ensuring comprehensive learning. Expertise in natural language processing (NLP), machine learning (milliliter), and information retrieval (IR) is essential for developing and implementing effective misinformation detection and mitigation strategies. This expertise is required to design algorithms and models that can accurately identify and filter false information. Fine-tune parameters. Fact-checking thresholds determine the level of certainty required for a claim to be considered accurate. Source credibility weights assign different levels of trust to various sources based on their reputation and reliability. Bias detection parameters fine-tune the system's ability to identify and mitigate subtle forms of bias in language and framing. Hyperparameters for the machine learning milliliter models used in the chatbot's training and inference phase play a critical role in determining the model's accuracy and effectiveness in identifying misinformation. These parameters need to be carefully tuned to optimize performance. Metrics. Evaluating the chatbot's performance requires the use of standard metrics like accuracy, precision, recall, and F1 score. These metrics measure the chatbot's ability to correctly identify and classify accurate and inaccurate information. Beyond technical metrics, user satisfaction, trust in chatbot responses, and the number of misinformation flags are crucial indicators of the chatbot's effectiveness in mitigating the spread of false information. High user satisfaction and trust, along with a minimal number of misinformation flags, signify a successful implementation. Visualization plots. Visualizations such as confusion matrices, ROC curves, and the distribution of confidence scores can provide insights into the chatbot's performance. These plots help identify areas where the chatbot may be struggling and guide the development of improvement strategies. Visualizing identified misinformation sources and their characteristics can help understand the nature of misinformation being spread. This includes identifying the types of sources, their motives, and the characteristics of the information they spread. Error analysis. Identifying instances where the chatbot generated inaccurate or misleading responses is essential for improving its performance. This involves analyzing the chatbot's responses and identifying patterns of errors. Understanding the reasons behind errors is crucial for developing effective strategies to mitigate them. This may involve analyzing the training data, identifying weaknesses in the model, or refining the algorithms used for fact-checking and bias detection. Challenges and fixes. Challenge 1. Detecting subtle forms of misinformation, such as biased language or framing, poses a significant challenge. Subtle forms of misinformation can be difficult to identify due to their reliance on subtle linguistic cues and framing techniques. Fixes to Challenge 1. Developing more sophisticated NLP techniques that can effectively identify subtle forms of misinformation, such as biased language, framing techniques, and emotional appeals, is essential. Training the chatbot on a more diverse and nuanced dataset that includes examples of subtle misinformation is crucial. This exposure helps the chatbot learn to recognize these subtler forms of manipulation and respond accordingly. Challenge 2. Balancing the need for accuracy with the need for conversational fluency is a delicate task. While accuracy is paramount, the chatbot should also be able to communicate information in a natural and engaging way. Fixes to Challenge 2. Fine-tuning the chatbot's language generation capabilities to ensure accurate and natural-sounding responses is crucial. This involves finding a balance between providing factual information and maintaining a conversational tone. Providing users with clear and concise explanations of the chatbot's reasoning when answering questions enhances transparency and trust. It allows users to understand the chatbot's thought process and the sources it relies on. Challenge 3. Maintaining up-to-date information in a rapidly changing world presents a major challenge. As new events unfold and information is constantly updated, chatbots need to adapt and remain relevant. Fixes to Challenge 3. Implementing continuous learning mechanisms to keep the chatbot's knowledge base updated is essential. This involves regularly feeding the chatbot with new information and adjusting its knowledge base accordingly. Integrating real-time information sources, such as news feeds and social media platforms, allows the chatbot to access the latest information and respond to user queries with current knowledge. This ensures the chatbot remains informed and provides relevant responses. Continuous improvement. A systematic and ongoing effort to enhance processes, products, services, or systems within an organization. It involves identifying areas for improvement, analyzing problems, implementing solutions, and measuring the impact of changes. The goal is to achieve continuous progress and achieve higher levels of efficiency. Effectiveness. and customer satisfaction. Inputs: data, raw information collected from various sources within the organization, such as sales figures, customer feedback, process performance metrics, and operational data. This data is essential for identifying areas for improvement and analyzing problem root causes. Feedback: information received from customers, employees, or stakeholders regarding their experiences with the organization's processes, products, or services. Feedback can be formal surveys, reviews, or informal comments, suggestions. It helps identify areas where improvement is needed and understand customer expectations. Outputs: improved processes, optimized workflows, procedures, and systems that are more efficient, effective, and streamlined. These improvements may involve simplifying processes, automating tasks, or introducing new technologies to enhance productivity and reduce errors. Increased efficiency: the ability to achieve desired results with minimal waste of resources, time, money, materials, and effort. Continuous improvement efforts aim to minimize waste, optimize resource allocation, and maximize output, leading to cost savings, faster turnaround times, and improved productivity. Working methodology: identify areas for improvement using data analysis, feedback, and observation. The organization pinpoints processes, products, or services that require attention and can benefit from improvement. This involves identifying areas with high error rates, customer dissatisfaction, or inefficiency. Implement changes and measure results once areas for improvement are identified. The organization implements changes, such as process modifications, training programs, or technology upgrades. After implementing changes, it's crucial to measure the impact of those changes to determine their effectiveness and identify areas for further optimization. Prerequisites: existing processes: the organization must have defined and documented processes in place. This provides a baseline for analysis, improvement, and measurement. Having well-defined processes allows for clear understanding of current practices and identification of areas for optimization. Data collection methods: robust data collection methods are necessary to gather relevant information for analyzing processes, identifying improvement opportunities, and measuring results. This includes implementing systems for tracking key metrics, collecting customer feedback, and monitoring process performance. Fine-tune parameters, process metrics, key performance indicators (KPIs) that measure the effectiveness and efficiency of processes. Examples include cycle time, defect rate, customer satisfaction score, and cost per unit. These metrics provide a quantitative basis for evaluating process performance and identifying areas for improvement. Improvement goals: specific, measurable, achievable, relevant, and time-bound objectives that define the desired level of improvement. Setting clear goals provides direction and motivation for improvement efforts and helps track progress towards achieving desired outcomes. Metrics: process efficiency, a measure of how effectively processes utilize resources, time, money, materials to produce desired outputs. Efficiency can be measured by analyzing metrics like cycle time, defect rate, and resource utilization. Customer satisfaction, a measure of how satisfied customers are with the organization's products, services, and processes. This can be assessed through customer surveys, feedback mechanisms, and complaint analysis. Visualization plots, control charts, visual representations of process data over time, used to monitor process stability and identify potential variations or trends. Control charts help detect and analyze unusual patterns in process performance, indicating areas where improvement efforts may be needed. Pareto charts, bar graphs that display the frequency of different types of defects or problems in a process. The chart is arranged in descending order of frequency, with the largest bar representing the most frequent problem. Pareto charts help prioritize improvement efforts by identifying the most significant contributors to process issues. Error analysis. Root cause analysis, a systematic approach to identifying the underlying causes of problems or defects. It involves asking why repeatedly to uncover the root causes that contribute to the observed problem. Root cause analysis is essential for developing effective solutions that address the underlying issues rather than just treating symptoms. Process mapping, a visual representation of a process, showing the sequence of steps, decision points, and inputs/outputs. Process mapping helps visualize the flow of work, identify potential bottlenecks, and identify areas for streamlining more automation. Challenges and fixes. Resistance to change. People may be reluctant to embrace new ideas or processes, especially if they feel threatened by change or are comfortable with existing practices. Communication and training. Effective communication and training programs can help overcome resistance to change by educating employees about the benefits of improvement efforts, addressing their concerns, and providing the necessary skills and knowledge to implement new processes. Lack of data. Insufficient or inaccurate data can hamper the identification of areas for improvement, the analysis of problem root causes, and the measurement of results. Implement data collection methods. Establish systems for collecting accurate and timely data from various sources, such as process performance metrics, customer feedback, and operational records. This data is crucial for supporting informed decision making and driving continuous improvement. Insufficient resources. Organizations may face challenges with limited time, budget, or personnel to dedicate to improvement initiatives. Prioritize improvement efforts. Focus on high impact areas that offer the greatest potential for improvement and align with organizational goals. Prioritizing efforts ensures that resources are allocated effectively and that improvement initiatives deliver tangible benefits. Ethical considerations. This section outlines the ethical considerations that must be taken into account when developing and deploying a machine learning model for fraud detection in financial transactions. Inputs. Transaction data. This includes information such as the amount of the transaction, the merchant, the location, the time of the transaction, and the account holder's information. Historical data. This includes information about previous fraudulent transactions, as well as information about legitimate transactions. This helps to train the model to identify patterns that are associated with fraud. Outputs. Fraud score. This is a numerical score that represents the probability that a transaction is fraudulent. The score is typically based on the model's prediction, and it can be used to flag transactions for further review. Fraud detection decision. Based on the fraud score, the model may decide to block a transaction, flag it for further review, or approve the transaction. This decision is typically based on a threshold, which is set by the financial institution. Working methodology. Data preparation. This step involves cleaning and preparing the data for training the model. This includes handling missing values, converting categorical variables to numerical values, and scaling the data. Model training. This step involves using the prepared data to train the machine learning model. The model learns from the historical data and identifies patterns that are associated with fraud. Prerequisites. Large datasets. A large amount of historical data is required to train the model effectively. This data should include both fraudulent and legitimate transactions. Domain expertise. It is important to have domain expertise in fraud detection to understand the types of fraud that are likely to occur and to design the model accordingly. Fine-tune parameters. Learning rate. This parameter controls how quickly the model learns from the data. A higher learning rate will result in faster learning but may also lead to overfitting. Regularization. This parameter helps to prevent overfitting by penalizing the model for being too complex. Metrics. Accuracy. This metric measures the percentage of transactions that are correctly classified as either fraudulent or legitimate. Precision. This metric measures the percentage of transactions that are classified as fraudulent that are actually fraudulent. Visualization plots. Receiver operating characteristic ROC curve. This plot shows the trade-off between the true positive rate and the false positive rate for different thresholds. Precision recall curve. This plot shows the trade-off between precision and recall for different thresholds. Error analysis. False positives. These are transactions that are incorrectly classified as fraudulent. False positives can lead to inconvenience for customers, as their legitimate transactions may be blocked. False negatives. These are transactions that are incorrectly classified as legitimate. False negatives can lead to financial losses for the financial institution, as fraudulent transactions may be approved. Challenges and fixes. Challenge 1. Data imbalance. This is a common challenge in fraud detection, as fraudulent transactions are typically much rarer than legitimate transactions. This can make it difficult to train a model that can effectively identify fraud. Fixes. This can be addressed by using techniques such as oversampling, undersampling, or using cost-sensitive learning algorithms. Challenge 2. Evolving fraud patterns. Fraudsters are constantly changing their tactics. This makes it difficult to train a model that can keep up with the latest fraud trends. Fixes. This can be addressed by regularly retraining the model with new data and by using techniques such as anomaly detection. Implementing fairness measures involves using techniques to mitigate biases in AI systems. This can include data preprocessing to remove biased information, algorithmic adjustments to promote fairness, and the use of fairness metrics to evaluate the effectiveness of bias mitigation efforts. Conduct impact assessment. Impact assessment in AI involves evaluating the potential consequences of deploying AI systems. This can include assessing the impact on individuals, communities, and society as a whole. Impact assessment helps identify potential risks and benefits of AI systems and ensure that their deployment is responsible and ethical. Prerequisites. Ethical guidelines. Ethical guidelines provide a framework for developing and deploying AI systems responsibly. These guidelines often specify ethical principles such as fairness, transparency, accountability, and privacy, and they can be used to guide decisions throughout the AI development process. Stakeholder engagement. Stakeholder engagement is essential for ensuring that AI systems are developed and deployed in a way that aligns with the needs and values of all stakeholders. This involves engaging with individuals, communities, and organizations that may be affected by AI systems, gathering their input, and addressing their concerns. Data integrity. Data integrity is fundamental to the development of ethical AI systems. It ensures that the data used to train AI models is accurate, reliable, and free from bias. Data integrity is crucial for building trust in AI systems and ensuring that they make accurate and fair predictions. Fine-tune parameters. Fairness metrics. Fairness metrics are used to evaluate the fairness of AI systems. These metrics measure the extent to which AI systems treat individuals equitably, regardless of their protected characteristics. Fairness metrics can be used to identify and quantify biases in AI systems and guide bias mitigation efforts. Bias mitigation techniques. Bias mitigation techniques are methods used to reduce biases in AI systems. These techniques can include data preprocessing, algorithmic adjustments, and the use of fairness metrics. Bias mitigation techniques are essential for ensuring that AI systems are fair and unbiased. Metrics. Fairness metrics. Fairness metrics are quantitative measures used to evaluate the fairness of AI systems. These metrics can include measures of equal opportunity, disparate impact, and calibration. Fairness metrics help identify and quantify biases in AI systems and guide bias mitigation efforts. Explainability scores. Explainability scores are measures of how well an AI system's decisions can be understood and explained. These scores can be used to assess the transparency of AI systems and ensure that users can trust and understand the logic behind their decisions. Visualization plots. Bias visualization. Bias visualization involves creating visual representations of biases in AI systems. This can include graphs, charts, and maps that illustrate the distribution of bias in data or predictions. Bias visualization helps identify patterns of bias and make the issue more readily understandable. Impact assessment plots. Impact assessment plots are visual representations of the potential impacts of AI systems. These plots can show the potential benefits and risks of AI systems, including their impact on different groups of people, communities, and industries. Impact assessment plots help stakeholders understand the potential consequences of deploying AI systems. Error analysis. Identify ethical errors. Identifying ethical errors in AI systems involves analyzing the system's behavior and identifying instances of bias, discrimination, or other ethical violations. This can involve reviewing data, algorithms, and predictions, and looking for patterns of unfair or discriminatory outcomes. Conduct root cause analysis. Root cause analysis in AI involves investigating the underlying causes of ethical errors. This can involve tracing the error back to its source, whether it be in the data, the algorithm, or the deployment process. Root cause analysis helps identify the source of ethical problems and inform solutions to prevent similar errors in the future. Challenges and fixes. Data bias. Data bias occurs when the data used to train AI models contains systematic errors or biases that reflect existing societal inequalities. This can lead to AI systems that perpetuate these inequalities, making unfair or discriminatory predictions. Data collection strategies. Addressing data bias requires implementing data collection strategies that minimize the introduction of bias. This can involve carefully selecting data sources, ensuring that data is representative of the population it is intended to serve, and using techniques to correct biases in existing datasets. Model bias. Model bias occurs when the AI model itself learns and reflects biases present in the training data. This can lead to AI systems that make unfair or discriminatory predictions, even if the data itself is not biased. Bias mitigation techniques. Addressing model bias involves implementing bias mitigation techniques during model development. This can include using techniques to identify and remove bias from the model, or adjusting the model's parameters to promote fairness. Algorithmic transparency. Algorithmic transparency refers to the ability to understand how AI algorithms make decisions. This is essential for ensuring that AI systems are accountable and trustworthy. Explainable AI methods. Addressing algorithmic transparency involves using explainable AI methods to provide clear and understandable explanations of how AI systems make decisions. XAI methods can help users understand the logic behind AI outputs and build trust in the system. Data protection. Protecting sensitive information stored in the knowledge base. Protecting sensitive information within a knowledge base is crucial for maintaining data integrity and ensuring compliance with relevant regulations and standards. Inputs. Sensitive data stored within a knowledge base, including information such as customer details, financial records, proprietary business data, and confidential research findings. For example, this might involve storing personally identifiable information like names, addresses, and social security numbers for customer relationship management (CRM) purposes. Data access policies and security protocols, which define how data is accessed, managed, and protected. Examples include role-based access control (RBAC), where users are granted specific permissions based on their roles within the organization, and encryption techniques to secure data both at rest and in transit. Outputs. Protected sensitive information stored securely within the knowledge base. This means ensuring that unauthorized access is prevented and data integrity is maintained. Auditing logs and reports that document security events and access patterns. These logs can track who accessed what data, when, and from where, providing valuable insights for security analysis and incident investigation. Working methodology. Implement robust access control mechanisms to restrict access to sensitive data based on defined permissions and roles. This involves configuring authentication systems, authorization policies, and access control lists (ACLs) to ensure that only authorized users can access specific data. Encrypt sensitive data both at rest, while stored in the knowledge base, and in transit, as it travels over networks. This involves using strong encryption algorithms and key management practices to safeguard data from unauthorized access and interception. Regularly audit security logs and access patterns to identify suspicious activities or potential security breaches. This includes monitoring for unusual login attempts, unauthorized data access, or any unusual behavior that could indicate a security risk. Prerequisites. A well-defined data security policy that outlines the organization's approach to protecting sensitive information. This policy should specify the responsibilities of different roles, the types of data that require protection, and the security controls to be implemented. Robust security infrastructure, including firewalls, intrusion detection systems (IDs), and anti-malware software, to protect the knowledge base from external threats and unauthorized access. Fine-tune parameters. Access control policies and rules should be configured to provide granular permissions and role-based access control. This allows for fine-grained control over who can access specific data, ensuring that access is granted only on a need-to-know basis. Encryption algorithms and key management practices should be carefully chosen and implemented to ensure strong data protection. Consider using industry-standard algorithms, such as Advanced Encryption Standard (ACE), and secure key management systems to safeguard encryption keys. Metrics. The number of unauthorized access attempts to sensitive data is a key metric to monitor. This can provide insights into the effectiveness of security controls and highlight potential vulnerabilities. Data breach incidents and their impact should be tracked to assess the effectiveness of security measures and identify areas for improvement. This includes recording the nature of the breach, the data affected, and the consequences of the incident. Visualization plots. Visualizations of access patterns and data usage trends can help identify anomalies and potential security risks. For example, graphs showing the frequency and location of data access can reveal unusual activity or potential unauthorized access. Security events and alerts over time can provide a historical view of security incidents and trends. This helps organizations understand the evolving threat landscape and proactively address potential threats. Error analysis. Identifying and analyzing security vulnerabilities in the knowledge base is critical for proactive security. This involves conducting regular vulnerability assessments, penetration testing, and security audits to identify and address weaknesses in the system. Assessing the impact of potential data breaches and security incidents is crucial for planning appropriate response and recovery strategies. This involves conducting risk assessments to understand the potential consequences of a breach and developing incident response plans to mitigate damage and restore operations. Challenges and fixes. Challenge 1. Balancing security with usability and accessibility of data is a key challenge when protecting sensitive information. Strict security measures can hinder the ease of access and use of data, while overly relaxed controls can increase the risk of unauthorized access. Implementing fine-grained access control mechanisms can provide appropriate access levels while minimizing risk. This involves defining specific permissions for different roles and granting access only on a need-to-know basis. Challenge 2. Ensuring data integrity and consistency during encryption and decryption is crucial for maintaining the accuracy and reliability of sensitive data. Incorrect implementation or weak algorithms can lead to data corruption or unauthorized access. Using robust encryption algorithms, such as Advanced Encryption Standard ACE, and secure key management practices can guarantee data integrity and confidentiality. This involves ensuring that encryption keys are securely stored and managed, preventing unauthorized access or compromise. Ethical considerations. Responsible AI development is a crucial aspect of building and deploying artificial intelligence systems that are aligned with ethical principles and societal values. It ensures that AI applications are developed and used in a way that promotes fairness, transparency, accountability, and respect for human rights. Inputs. Data used for training. This refers to the datasets used to train AI models. The quality, representativeness, and ethical implications of this data are crucial for building responsible AI systems. For example, training a facial recognition model on a dataset that is predominantly comprised of images of individuals from a specific ethnic group could lead to biased predictions when applied to individuals from other ethnic groups. Outputs. Explainability of model. The ability to understand the reasoning behind an AI model's predictions is essential for ensuring transparency and accountability. Explainable AI techniques provide insights into the model's decision-making process, allowing for the identification and mitigation of potential biases or errors. For example, a healthcare AI model predicting disease risk should be able to explain its reasoning to the healthcare professionals who use it. enabling them to understand the model's limitations and make informed decisions. Working methodology. Accountability and governance. This involves establishing clear responsibility for the development, deployment, and use of AI systems. It includes frameworks for ethical oversight, risk assessment, and mitigation of potential harm. For example, a self-driving car AI system should have clear accountability mechanisms in place for accidents or unexpected behavior. Prerequisites. Data privacy policies. These are rules and regulations that protect the privacy and security of personal data. They dictate how data can be collected, used, and shared, and they are essential for ensuring responsible data handling in AI development. For example, the California Consumer Privacy Act (CCPA) outlines the rights of individuals to access, delete, and control their personal data. Fine-tune parameters. Privacy-preserving techniques. These are methods used to protect the privacy of individuals' data. During the development and deployment of AI systems, they aim to minimize the risk of data breaches and ensure that sensitive information is not disclosed or misused. For example, differential privacy adds noise to data to protect individual privacy while still enabling statistical analysis. Metrics. Privacy metrics. These are measures that assess the privacy risks associated with the collection, use, and disclosure of data in AI systems. These metrics help to identify potential vulnerabilities and ensure that the development and deployment of AI systems comply with privacy regulations. Visualization plots. Privacy risk assessment plots. These are visualizations that illustrate the potential privacy risks associated with the use of data in AI systems. They help to identify and evaluate vulnerabilities and guide the development of privacy-preserving AI systems. Error analysis. Evaluating privacy risks. This involves assessing the potential privacy risks associated with the collection, use, and disclosure of data in AI systems. Challenges and fixes. Robust governance frameworks. These are frameworks that establish clear guidelines and mechanisms for ethical oversight, risk assessment, and accountability in the development and deployment of AI systems. They help to ensure that AI is used responsibly and ethically, mitigating potential risks and promoting trust in AI technologies. Word cloud visualizations. Creating visual representations of the most frequent words used in the message. Highlighting key themes and ideas. Misinterpretation of cues. Analyzing errors in the process that result from misinterpreting subtle cues or nonverbal signals, potentially leading to misunderstanding. Over-reliance on literal meaning. Identifying instances where the process focuses too heavily on the literal meaning of words and fails to consider implicit meaning. Challenge 1. Ambiguity in language, where words or phrases have multiple possible meanings depending on the context. Fixes to challenge 1. Consider multiple interpretations. Exploring different possible interpretations of ambiguous language. Considering the context and available information. Seek clarification when needed. If ambiguity remains, seeking further clarification from the speaker or source of the message to resolve the uncertainty. Challenge 2. Cultural differences in communication, where different cultures have different norms and conventions for language use. Fixes to challenge 2. Research cultural norms. Understanding the specific cultural context of the communication, including language conventions, nonverbal cues, and social norms. Be aware of potential misunderstandings. Being mindful of potential misunderstandings that could arise due to cultural differences and actively seeking to avoid them.